So we are continuing with the redox reaction. This is our lecture number 2. Now question is define oxidation number and discuss rules to calculate oxidation number of the atoms in the combined state. So what is oxidation number? It is the residual charge left on an atom when all the other atoms attached to it are separated as ions. So it is the charge left on the atom when all the other atoms which are attached to it in the compound, they are removed as ions, or in other word we can say it is the number of electrons lost or gained by an atom during compound formation. Let us demonstrate this concept. We have H2SO4 from sulfur. We remove 2 hydrogen in the ionic form. We remove 4 oxygen in anionic form. We get sulfur as +6 here. So this is the oxidation number of sulfur. Similarly, we are saying the number of electrons lost or gained by the atom during formation of compound or during a reaction. So copper has lost, zinc lost 2 electrons. Oxidation number will be positive now. Copper gained 2 electrons. Oxidation number is again 2 here. So oxidation number, it is the number of electrons lost or gained by a species during the reaction. It was +2 in the beginning, now it is 0. So it gains 2 electron, oxidation number will be now gains 2 electron, oxidation number is 2 here. So this is the oxidation number. Then we have H2O. When we remove 2 hydrogen in the positive form, oxygen has 2 negative charge. This is the oxidation number of oxygen here. Then we come to the next rules for calculation of oxidation number. Here oxidation number decreases by 2 units. Here oxidation number increases by 2. Now rules to calculate oxidation number. First is the oxidation number of alkali metals is always +1. Oxidation number of alkaline earth metals, group number 2, it is +2. Oxidation number of fluorine always -1. Oxidation number of oxygen -2, except its compounds with fluorine. Where it is present in positive oxidation state. Here oxygen is +2. in O2 F2, it is in +1 state. Otherwise, oxygen is present in -2 state. Oxidation number of halogens Cl, Br, I generally -1, but it may be +1, +3, +5, +7 when they share 1, 3, 5 and 7 electrons with the electropositive, electronegative atoms. Then we have the oxidation number. For calculation purposes, what we do, calculation of oxidation number. First step, write oxidation number of each atom above its symbol, and X for that atom whose oxidation number is to be calculated. Write total oxidation number below the symbol. Calculate total charge equated to 0 in neutral molecule and to charge in case of ions. So now we calculate the oxidation number of some of the species in the combined state. Let us now solve a problem. Calculate oxidation number of manganese in MnO4 negative ion, KMnO4, this is underlined here, K2MnO4, MnO2. So in these spaces we have to calculate the oxidation number of Mn. Taking first case MnO4 negative, write X for Mn, -2 is the oxidation number of oxygen. Calculate it total, 1 multiplied by X, 4 multiplied by -2, it is equated to -1. So X will be +7. Then we have second case KMnO4. +1 is the oxidation number of potassium. Oxygen -2, it is X. X plus 1 minus 8, that is equal to 0 because KMnO4 is neutral species. So X is again +7 here. In case of the K2MnO4, write +1 here. +1 multiplied by 2, you get +2. X multiplied by 1, we get X. And -8, so X plus 2 minus 8, that is 0. X is equal to +6. In this case, X minus 2, X minus 4 equal to 0. X will be equal to +4. So this is the calculation of oxidation number of Mn in different species. Then we come to the calculation of oxidation number of Cr. in K2Cr2O7, K2CrO4, Cr2O3, Cr2O7. Here it is plus 1 minus 2 x, so x2x plus 2 minus 14, that is equal to 0, x will be equal to 6. In this case plus 1 plus 2 total, this is x minus 8. So x plus 2 minus 8, this will be equal to 0, x will be equal to 6 here. In this case x for 8 minus 2, 2x minus 6, x will be equal to 3 here. In this case minus 2x, 2x minus 14 equal to 0, x is equal to plus 7. So this is the way how to calculate the oxidation number of the different species in case of the molecule. Then we have calculate oxidation number of sulfur in H2 SO4, H2 S2o7, H2 SO3, H2 S2o3. In H2SO4 it is simple x plus 1. For hydrogen it is x minus 2. So x plus 2 minus 8, that is equal to 0, x is equal to plus 6. In this case let us see what is the structure of H2 S2o7. So in this case oxidation number of sulfur will be x plus 1 minus 2. So you will be having 2x plus 2 minus 14. It will be x will be equal to 6. In H2SO3 we see the oxidation number. It is plus 1 of hydrogen minus 2x. X plus 2 minus 6 equal to 0, x will be equal to 4 here. In H2 S2o3 the structure of this is like this. H2 S2o4. This has the structure like this. H2 S2o3. Now here the oxidation number of sulfur will be taken. When similar types of atom they are joining, the oxidation number is taken to be here 0, and here it is having 4. This sulfur is having no oxidation number, this is having 0, and this sulfur is having oxidation number of 4. So if you want to calculate the oxidation number of this sulfur, let it be calculated. So we calculate hydrogen, we are adding plus 1 and 0 for one sulfur, another sulfur is to be calculated, that is x here minus 2. So now we have the equation x plus 2 minus 6, that is equal to 0, x will be now equal to 4 in this case. So one sulfur is present in plus 4 state, another sulfur is present in 0 oxidation state. When bond is formed between a similar atom, then oxidation number of those species is taken to be 0, because similar atom they neither lose electron, neither they gain electron, but they share electrons. Then we calculate the oxidation number of carbon in some of the species. They are oxalate ion. calculate oxidation number of carbon in CO2, C2O4 2 negative, C12H22O11 and glucose. So we will be calculating one by one. CO2, let it be x minus 2, x minus 4, that is equal to 0, x will be equal to plus 4 here. In C2O4 2 negative, write x minus 2, 2x minus 8, that is equal to minus 2, x will be equal to what? It will be 3. In this case, write x for carbon, plus 1 for hydrogen, minus 2 for this. So 12x plus 22 minus 22, it will be 0 in this case. And we have C6 S12, again it will be 0, x plus 1 minus 2. So x minus 12 plus 12 minus 12, again x is 0. So in this manner we can calculate the oxidation number of the different species in the molecules given to us. Then we discuss another concept of oxidation and reduction on the basis of your oxidation number. So this is our next question. Define oxidation reduction, reducing agent and oxidizing agent in terms of oxidation number. Now oxidation number, in terms of oxidation number we are discussing oxidation, the process which is accompanied by increase in oxidation number. For example, Zn loses 2 electron. So oxidation number was 0 in the beginning, now it is plus 2. So oxidation number increases by 2 units. This is oxidation. Copper loses 2 electron. Here it is again oxidation, 0 to plus 2. Increases by 2. Then we have second definition, that is reduction. Reduction is the process where oxidation number decreases. For example, Cu2 positive take up 2 electron, gives Cu. 2Ag positive take up 2 electron, will give you 2Ag. So this process is reduction, which is taking electron. Cl2 takes up 2 electron, making 2Cl negative. This is reduction. So up to now we have discussed oxidation and reduction. Now we come to the oxidizing agent, the substance whose oxidation number decreases. Here these are all the oxidizing agent, because oxidation number is decreasing. In this case, plus 2 0, plus 1 to 0, 0 to minus 2. So all the oxidation number, they are decreasing. Then we have reducing agent. Oxidation number increases. So this is reducing agent here, Zn, copper, reducing agent, because their oxidation number is increasing. Then substance, after losing electron, it is said to be oxidized, or the species whose oxidation number increases is oxidized, and the species whose oxidation number decreases is said to be reduced. So reduced species are those species whose oxidation number has decreased during the reaction, and you are reducing oxidized species are those whose oxidation number is increased during the reaction. So this is regarding the reducing agent, oxidizing agent in terms of the electronic concept of the oxidation and reduction. Now we come to the nomenclature of the inorganic compounds. Discuss naming of inorganic compounds. Sometimes it has been observed that a same substance can exhibit two oxidation states in different compounds. So for lower oxidation state, the name of the metal was ended as OUS. This is called as ferrous chloride. For higher oxidation state, the name of the metal was ended as IC, ferric chloride. So this is ferrous. This is ferric. But there was a problem in these types of the compound where metal shows variable valency. It can show +4, +5, +7 valencies iron, and then how many cases we can use IC, in how many cases we can use OUS. So it was problem in those cases where metal exhibited the number of valencies shown variable valencies, and mainly in case of the transition metals and inner transition metal it was seen. Therefore Albert Stark gave a new system. According to this system, the oxidation number of the metal should be written after its name, after its symbol, in Roman numerals in the small bracket. We should not mention OUS, IC in the ending because that was creating a problem. So Albert Stark introduced a system of oxidation number where the name of the metal it was followed by the oxidation number of the metal ion in the compound, that is written in the Roman numerals in the small bracket. So it became very easy to name all the inorganic compounds in such cases. Now let us name some of the compound on the basis of Albert Stark system. Let us take, first of all, we take Cu2O. Here oxidation number of copper is 1, so you will be writing copper 1 oxide. We have SnO2. Here oxidation number of tin is +4. We write tin 4 oxide. We have SnO, tin 2 oxide. We have FeCl3, iron 3 chloride. We have FeCl2, iron 2 chloride. SnCl4, tin 4 chloride. Then we have SnCl2, tin 2 chloride. We have K2Cr2O7. This is potassium dichromate, where Cr is +7 here, +6. Then we have K2CrO4, potassium chromate. Here this is in -6 again. So we are mentioning the oxidation number after the metal, name of the metal. Na2CrO4 will be written as sodium chromate, chromium is in 6 oxidation state, B2O5, vanadium, pentoxide, 5 pentoxide, or we can write vanadium oxide, vanadium 5 oxide is also written. So in this case, the oxidation number of the species, that is to be written just after the name of the metal.